So under suitable conditions, the rate at which the temperature of a hot object decreases may be taken to be proportional to the difference between the temperature of the hot object and the temperature of its surrounding. So theta is the temperature of the hot object. So D, in other words, the rate at which the temperature of hot object decreases is just d theta dt. So this part we call it d theta dt, right, may be taken to be proportional, so K, to the difference between the temperature of the hot object and the temperature of its surroundings. So temperature of hot object is theta, right, and its surrounding, so minus what is the temperature of surrounding has a constant value of theta naught, right, so minus theta naught. So this is the summary of saying the rate of change of the temperature of hot object is proportional to the difference between the temperature of a hot object and its surrounding, right. So next, express this information as a differential equation connecting theta and dt. Okay, show that the general solution of the differential equation may be expressed in the form this one. So I'll bring the theta over to the side of the theta, so I just theta minus theta naught, and this dt I'll bring over, so I'll just get k dt, and then we solve this. Take note, this is just a constant, right? So then this will be using the equation, the formula f prime theta over f theta d theta equals to ln f theta plus c, right? So because now the denominator only denominator is theta minus theta naught. When we differentiate theta minus theta naught with respect to theta, we get 1. So it's exact in this form. So we just need to, this part will change to ln modulus theta minus theta naught. So equals to, integrate this, k is just a constant, so integrating a constant gives me this. So C, question, sometimes student ask why there isn't a C on this side. Okay, the C on this side can be combined with the C on this side to form a the constant on this side to form C, right? So we don't have to write two C's, right? Because we don't know the value of this C. This C can be the sum of the constants on both sides, alright? Or the subtraction of the constants on both sides. So then theta minus theta naught equals to E k t plus C. And using the exponential rule, this is just E k t multiplied to EC. And we can write EC as another constant, because exponential of a constant is a constant. And so we have this, and where A equals to EC, and where C is an arbitrary constant that we don't know. When a constant is unlike an unknown, it's just one number, just that we don't know what is that number, right? Then it's not a variable, as in show that the general solution may be expressed in the form this one. We have already achieved it, right? We just need to switch the equation to theta. We just bring the theta naught over to the other side. We have theta naught plus AEKT, and that's it. Why is there a minus k and a minus the k? Actually, k is a constant. It doesn't matter whether it's minus or plus, but since we are talking about decreasing and we assume k to be a positive constant, if we assume k to be a positive constant, then we have to put a minus to show that this is actually decreasing. If I put a minus here, I'll have a minus everywhere. And that is how we get AE minus KT. Right. Actually really doesn't make a difference because K is also just a constant. Where K is a constant, okay, in this case positive. If I didn't put this negative, then my K would be a negative constant. Alright, that's it. Then the next part of the question, this is the general equation, and we want find in terms of t the value of t when theta equals to 2 theta naught. Okay, to do this we need to make use of the information given. Okay, so when t equals to 0, theta equals to 5 theta naught. Therefore 5 theta naught equals to theta naught plus AE minus K 0. Therefore 4 theta naught equals to A. Okay, then what about my K? I also need to find my K. So when t equals to big T, theta equals to 3 theta naught. So theta equals to 3 theta naught here equals to theta naught plus, now we know that A equals to 4 theta naught. Right. Oops. I've been writing the 0 on top when it should be below. Right, so I just write the 0 below. No, it's just theta naught, okay? It's not a degree. Just avoid the confusion. 3 theta naught equals to theta naught plus 4 theta naught E minus KT. Right, here will be theta naught 2. And then we will have, and the T, no, the T should be the big T. Okay, so then this would be 2 theta naught equals to 4 theta naught E minus KT. That means E minus KT equals to half. And this implies KT equals to minus ln half and minus can be carried over to this side because the ln rules a to the power minus 1. Therefore this one would be ln 2 because half to the power of minus 1 is just 2. Right, so KT equals to ln 2 and we are asked to find the value of T. Okay, so KT equals to ln 2 and so we'll substitute back in this, and this will substitute back into this equation and we will get theta equals to theta naught plus 4 theta naught KT equals to ln 2, so this is E minus ln 2. Alright, then we are asked to find the value of T. Wait, nope, not right. The T is not the same as this T. So E minus KT. This T is a different T. So we have to change it to in terms of k, so we need to find our k. So k is equals to ln 2 over big T. Alright, and this will mean that the equation is theta naught plus 4 theta naught e minus ln 2 over t. Okay, and then we want to find the value when the value of t equals to theta equals to 2 theta naught. So theta, when theta equals to 2 theta naught, I want to know what is my t. Okay, and this one will mean that 2 theta minus theta naught is theta naught. Theta naught divided by 4 theta naught is 1/4. 1/4, and the exponential I bring over will be ln 1/4 equals to minus ln 2 big T. So next, this is just t I'll bring over, so I get t, and minus ln 2 I'll bring over, I'll get, so that I'll get t equals to minus t ln 1/4 over ln 2, and 1/4 is just, okay, the negative I can carry up to this will become 4, so t ln 1/4 to the power of -1 is 4 over ln 2, and we know that ln 4 is just ln 2 square, right? So ln 2 square, right, quickly, ln 2 square, this 2 square is 4, so is equals to 2 ln 2 as well because of the ln rules. Then 2 ln 2, and 2 ln 2 over ln 2 will be 2, so t equals to 2t.